Let's start. So, yesterday we were looking at what is OS, right? Functions. OS is the manager. What does it manage? Processes. Then we saw what is scheduling, the two types of schedulings, and we also saw the advantage. Why is the response time better with round robin? Device management, we saw the device manager in the on the Windows operating system. Buffering, this is just a technique to uh, synchronize two entities which operate at different speeds. Okay, because CPU is faster and our input device is slower, we added a buffer here in the middle. Similarly, CPU is faster, but the output device, the maybe the printer or the monitor is slower. That's why we added a buffer. Even in case of YouTube videos, maybe uh, the YouTube server is able to send you enough data, but your network is slower. Maybe you are on just 2G network, so your video is going to buffer. It's going to wait for the network to be able to get all the data, and only then it will play the video.
Okay.
Right. So that's the main technique. Spooling, simultaneous peripheral operation. We saw the example of printer. I think that makes sense.
10K, it's
Yeah, 10K, it's 10 smartphone. Memory
one
management.
printer.
Yeah, in this we saw, right, key memory means primary memory. And how do we manage it? So we manage it by partitioning. Then we saw virtual memory. We can convert secondary memory into primary memory. And run programs which are larger than our primary memory. Okay, then this page map table helps us to figure out which part of the program is currently in the main memory and which part is in the secondary memory. And using this table, we can swap the thing whichever is needed. All right. So larger programs can be executed in main memory. Okay. We started with file system, right? So OS keeps information. Yeah. Any questions?
No.
Okay. So the file allocation uh, table. So operating system keeps information and it uses this fat table to store the data. Okay. This is the basic thing, like you can create files, you can edit files. Now,
But
how
is
does
it
the
even needed?
what?
Like the whole thing. Do I need to know about file management?
You have to be louder, I'm sorry.
Do I have to know about the file management? Is it going to be useful in future?
Yes, actually. Like when we start
Okay.
coding, there are file streams and all that. So there it helps to know how a file's organized and what is happening. And this is very
Okay.
important. You get to understand what is happening under the hood because of this. So there is a table. In the table we are keeping track of everything. Where is the
Okay.
file, the hierarchy. You have seen, right? Like inside this folder there are these many things.
Hmm.
To find this hierarchy, to give you this user interface, the OS has kept a fat table,
Hmm.
and because of that table it is able to uh, give you this structured output.
Hmm. Hmm.
Okay. Hmm.
Okay. Okay.
All right. The operating system also takes care that the files are opened with proper. Yeah. If you don't have access to some files, you cannot open them. Types of operating system, single.
So can
Hmm.
I? can I create something? Suppose I have really like secret pictures or videos in my PC,
Hmm.
and I do not want any other people to access it, right?
Hmm. Hmm.
And but I'm not a person who likes to lock my PC. Okay, it's not
Hmm.
locked,
Hmm.
but I have saved in suppose in I have saved it in somewhere.
Ah.
Okay, so can I lock the entire folder?
Yes. So,
So suppose somebody is very pro, like they can hack into anything.
hmm.
So is that safe?
No,
Are my
not really.
pictures okay?
Not really. Hmm.
Okay. So then I should not keep my private pictures anywhere saved.
Yes.
Because one Swastika told me even if you delete it, somebody is seeing them.
Mm, it can be recovered. So, okay, this is an interesting thing.
Mm,
Let's say this is your hard disk
mm,
and you have a picture, you stored it here. Okay. And let's say you deleted it.
mm,
So, after you delete it, the only thing, so we saw this fat, right? So, what this fat table will do is the fat table.
mm.
So let's say it will have two column. One will be the name and other will be the address.
Okay.
Okay. So let's say your file was something like pond.
Yes.
Okay. You had pond in your pond.jpg.
Mm,
For some reason, it was just a picture.
mm,
So, and there will be an address here.
mm,
Now, address will be like something 00x. It will be a hexadecimal number.
mm, mm.
Okay. What is a hexadecimal number? A number which has 16 digits.
Okay. Okay.
Like our numerics, the decimal number system has only 10 digits from 0 to 9. But this can also have the letter A, B, okay, C,
Okay.
and of course it can have the numbers. Okay.
Mm,
It will have a random address like this. Now, this address will be this will denote this is nothing but, so if I zoom in here at
mm,
this place, what you will see is hard disk is nothing but it is just a series of blocks and
mm,
each block has an address. Like this will have
mm,
00x1, 00x2,
mm,
00
mm,
x3. Okay, it will be
mm,
sequentially ordered. So this number will lie somewhere in this hard
mm.
disk. So wherever that
Yeah.
number is will be the starting point of your pond.jpg.
Okay.
So when you delete the file from your system,
Mm,
what you're doing is you're just deleting this entry.
mm, mm,
Okay, so you're not actually deleting this data. You're just deleting this reference. So what happens is now when you, let's say you became a good person and now you have some wisdom.jpg.
mm,
Okay, now when you store the wisdom.jpg, there is a probability, there is a chance that this
mm,
wisdom.jpg might overlap
mm.
completely. Maybe it will overlap only half, or maybe it will completely miss it. It will store it somewhere here. That depends on
Yeah.
OS's algorithm. We have no control over that. Okay, it will randomly allocate
Mm,
based on various factors.
mm,
Okay, so if your newly created image overlaps this, then your data can never be recovered. If it perfectly overlaps this place, so if this JPEG was also stored at this address and it was of exact same size, then it will probably exactly overlap this. Okay,
okay.
so then it won't be able to, it will never be recovered, this thing. But if it is stored at some other location, then you will be able to recover it because that data actually is present inside the disk. It's just that this file is not referencing it. That's the only difference. Okay, this is a very simplified explanation, but this is very close to what is actually happening in the
But the
computer.
process is really complicated.
Yeah, there are just other checks and a few more things happening at the same time. But this is the basic actual thing which is happening. There will be an address on the disk, a hexadecimal number, which will point to the starting location of the image. And this image is nothing but zeros and ones, right? All the data is zeros and ones you have seen
Zeros
in,
and ones.
yeah.
Yes.
So this will start this like it's 0010. This is the data. If this is your pond.jpg, then it will start from here 0010. This is how it will be exactly stored in the hard disk. Okay.
Mhm.
So this is how people are able to recover it because your memory is not perfectly overlapped.
Yes.
Okay.
Hmm.
So we also understood what is fat. This is the table, like where is the file. So if there are folders, then this table might become more complicated. It might have more columns. But this was the basic crux. Okay. Any more questions?
No.
So type of OS, single user, single task. These are like generic, not very important. So we can quickly read it. It is used on a standalone single computer for performing a single task. Personal computers are single user OS. Single users are simple operating designed to manage one task at a time. MS-DOS was an example of single user OS. Our Windows is not a single user because you know, right? There are multiple profiles created on the system. One is the admin user, then you might be one of the users. Maybe your laptop
Yes.
was being used by some other person before. So that profile might also be present on your laptop. Okay.
No, what if no no? What if I buy a new laptop? It is entirely owned by me, bought by me. Then only it is run by somebody else. Can it happen?
You buy a new laptop, then what?
So it is completely owned by me, right? So there is where I am the administrator, right?
Yeah, you will be the administrator, but you will be able to create more users if you want. Like if you want to
Okay.
lend your laptop to someone, you so your Windows OS is not a single user OS. There can be multiple users. Okay. This is Windows. Like you are
So
example of
there can be multiple users if I want and if I am the administrator.
yeah, obviously.
Otherwise, not.
Yeah, we saw right here somewhere. Ki it comes under device management. There is user management as well, responsibility of OS. But the multiprocessing OS, two or more processors. So these days, the computer which we have, it's multi OS, multi-processing, time sharing. Okay, it's all that. We have a lot of cores, right?
Hmm.
So each processor works on different parts of the same task or on two or more different tasks. Single execution takes place in parallel. So they are used for high speeds. So I'll tell
Okay.
you interesting thing.
Hmm.
Uh, see, multiprocessing is being able to process multiple processes,
Hmm.
right? You know what a process is. What is a process? I don't want the definition. Just tell me. Give me an example.
It's a process. Okay. Uh, but wait a second. So actually a program, like suppose Chrome is running. Chrome is a process.
Chrome is a process. Chrome.exe will be the exact process you will see in the task manager.
Hmm. Then Microsoft Word.
Sorry?
Microsoft Word.
Microsoft Word, yes.
Hmm.
So multiprocessing, then there is multi-core. This is a what action word? I should say multi-process, multi-core, and multi-threading. Okay, now this is a verb. There is nothing
Multi-threading.
called multi-coring. Okay,
What is
uh,
multi-threading?
yeah. So these are all real words. So we'll try to see what is the difference between all this. So multi-process, you can understand. Process is Chrome, Firefox. We can run multiple things. Like right now, I'm running multiple
So
things.
why are you saying process when you can just say program?
Program is just a set of instruction, right? Process is when that program is executed, a process spins up. There is a difference,
Okay. Okay.
right? The code for Microsoft thing is it's for Chrome will be written somewhere. When you download it, you are just downloading the source code. You're not downloading the process. And when you double click on that exe, then you are executing that program and spinning up a process. Okay.
Okay.
Okay. Now let's see the difference. Let's see if it's able to understand.
Says multi.
Taking a lot of time. Multi-process,
Okay, I got it
multi-core.
right.
Okay, it got it. Okay. See, because they're related. So multi-core is a hardware concept. A CPU with multiple independent cores on a single chip. Okay. So you would have heard quad core CPU, even in mobile phones. Octa core, quad core, dual core,
Yes. Yes, yes.
right?
Yes.
So like the first CPU that I ever used was Pentium 4. And that was single core, I think.
Very
Pentium
excited.
core processor. Yes.
So you got your first
See,
computer in
from
okay.
1993. All right.
Okay.
So it was Pentium 2 is what I had, I feel. Because it used to show up when I used to boot up the computer.
Okay.
Pentium 2 cores. Not a single core. See, so this was a single core processor. Then I got Intel Core 2 Duo, which had yeah, this one, exactly this one, which had two cores.
Okay.
Okay, so this Core 2 Duo was the successor, and then things changed. So look, a quad core CPU can run four tasks truly in parallel. So tasks and processes are like almost similar.
Okay.
Okay, so you can run
Okay.
four processes truly in parallel. Now, see, you can run Firefox, Notepad, and probably few more processes at a time on Pentium 2, which is a single core processor.
Okay.
That is because, like, when you are using Notepad, probably you won't be using Chrome at the same time. All
Okay.
right. But
But
what
what if I do?
if you do, then the PC will crash because it's a single core. It cannot do both. It will hang. Not crash, it will just
Okay.
hang. It will not be able to process it. So it will process the
Okay.
notepad input first, and then it will process whatever you're doing on Firefox first. So here it's truly parallel means I can actually, so like my, this thing has 8 cores, or probably 16 cores, I think. Yeah. So I can run 16 programs actually, like I can just split my screen like this, right? And I can pick up something here. So I can do simultaneously. All
Okay.
right. So that is what means truly parallel. Okay, so four chefs in one kitchen, each can cook a same dish at the same time. Okay, multiprocessing is a software plus hardware concept. So this we understood, ki running multiple processes at the same time. So
Yes.
each process will have its memory and It will run independently.
Okay.
See, so for multiprocessing, you don't need multi-core.
Okay.
Did you understand this?
But why?
I just explained कि in in a Pentium in a
Yeah, it's the
Pentium
two core
2
thing.
in the
Yes.
Pentium 2 processor, which had only
Yes.
single core, you
Yes.
can still run multiple processes, but you cannot interact with them at the same time.
Okay. Because
Okay.
it will hang.
Yeah. See,
So why was it made?
because we did not have the resources at that time. Technology
Okay.
was not
Okay.
advanced enough.
Okay.
See, let's say this is a Pentium computer. Okay.
Okay.
I have Chrome. Okay, there was Internet Explorer back then, and I have Notepad. Notepad was there.
Okay. Yeah.
Okay. Where is the text? Ah. So this is the Internet Explorer, IE.
Yeah.
All right.
Mm.
So no need to flip. This is Internet Explorer, and this is the Notepad.
Mm.
All right.
Mm.
So in a Pentium, so in a single core CPU,
Mm.
I cannot run both of these applications at the same time.
Mm.
So there was a word called truly parallel. Oh,
Okay.
okay. What does this mean? This means ki, okay, instead of Notepad, let me take a different example.
Yeah.
Okay, let's keep it Notepad. Let's say I'm writing something, I'm writing an essay.
Mm.
Okay. And I'm playing a video here.
Okay. Suppose you're listening to a song, the music
Yeah,
video is being played, and you're
hmm,
writing an essay.
much better. Music video, and I'm writing an essay. So
Mm.
to run this music video, you need a, you need a, you need CPU. Okay.
Okay.
So this is one process that is actually running. It is not in standby mode. See, right now this Chrome is open, but I'm not using it, right? So it can be in standby mode. Okay. So let's say the video is running and it is also doing some computation. So it's using CPU continuously. Okay. And when you are typing here, you are typing, then also you need CPU. But your CPU has only single core.
Mm.
So this won't happen when you click on notepad and you try to type, it will hang. It will not register your key presses. You'll have to stop this or maybe close it. If not close it, at least stop the video. And only then you will be able to type. Okay. But if you are, let's say you are, you have just opened it, but you have paused the video. And let's say it is not using the CPU, then in that case, you will be able to type here. So that will
Okay.
be called multiprocessing.
Yeah.
Okay. Let's say you opened a blog post here. Okay.
Yes.
Let's say you have opened a blog post and you're writing it here. You're copying it.
Okay. Mm-hmm.
Okay. So in that case, because you have just opened a static page, doesn't need CPU. So
Mm.
in that case, you both the applications will be running simultaneously. So it will be giving you a false sense of parallelism. Actually, because technically your two applications are running together, right? So you're running both the processes together. So that is multi processing.
What's this?
Because you're running two processes together, it
Yeah.
is a good thing that it is not using the CPU. Only one of the
Okay.
thing is using the CPU
Yeah.
because you have just opened a static text. It doesn't need CPU. It's in your memory. It's in your RAM.
Okay. Yeah.
So even if you have only single core CPU, it doesn't matter. So this is the difference between multiprocessing So this is why I said key you can do multiprocessing on a single core CPU.
Yeah.
Okay, make sense?
Yes.
Okay, I'll just do this.
But what is multi-threading?
Yeah, I'll come to that. To understand this, let's first understand threads versus cores. Okay, we understood CPU cores are physical processing units,
Yes.
while threads are virtual execution parts that allow core to handle multiple tasks simultaneously. So this is what I was saying. Ki this single core CPU was able to handle two processes
Okay.
because of multi-threading.
Okay.
Now, what a thread is? So let me show you. Let's say this is a CPU. Okay, CPU. Now this CPU will have, if it is a quad core CPU, it will have four cores. So there will be physically four separate cores on it. Okay, so core is a hardware thing. It has nothing to do with the software. Okay,
Okay.
so this is a quad core CPU. Now, let's say you're running these two applications on a computer. So this single core
Mhm.
can run these two processes
Mhm.
because of multi-threading. So what will actually happen is threads are just uh, so I was talking about false parallelism, right?
Yes.
So it gives you a sense of parallelism, but in it's not truly parallel. And we saw why it was not truly parallel. So when this single core is able to run two applications at the same time by context switching. Context switching is nothing but ki when you are on this browser. So like right now I'm using the paint. All right, I'm doing something here. The CPU is getting utilized because I'm giving input. The CPU is taking it into the buffer, processing it and showing it on the screen. Okay, I'm doing processing here. And when I go to this browser, then I'm searching or maybe interacting with something. So I'm getting the feeling I'm running browser as well and I'm running the paint as well at the same time. Okay, but actually I'm not, right. I'm doing it one by one. So the single core is able to run both the processes at the same time. Did you understand anything?
So, okay, it's very complicated,
Hmm.
first of all. Second of all, like whatever you said, the single code can run two processes at the same time.
Hmm.
But there is a difference between running and actually utilizing, right? Suppose I'm painting and I want to listen to horror podcast.
Hmm.
Okay.
Hmm. Hmm.
So will single core processor be able to do that, like play the video and then again writing the essay for me
Yeah,
or painting something?
yeah, really good question. So
Yeah.
actually the CPU is so fast that it will be able to do it.
But the moment I will open another program,
Hmm.
suppose I will open the sticky notes and I'll just write something.
Okay. Let me give you, can I open new? Can't I open pages in it? Okay, I can make it bigger. Good. Yeah. So see, you said you're running you're painting and
listening to
podcast.
podcast. Yes.
Okay. See, painting, let's say it requires CPU, and
Hmm.
this thing also requires CPU. Okay.
Yes.
We studied about buffers.
Yes.
Okay. So what happens is, see, this painting, just try to think about what do you do when you paint. Like I select something. Okay, I selected a paint. Okay, okay, I selected something. I moved my mouse here. I clicked my mouse and I dragged the mouse.
Hmm.
Okay, so see how I think I took around 5 seconds.
Hmm.
Okay, and at the same time, this podcast was also running.
Hmm.
So even though I was using paint, but for me to do one action, it took me 5 seconds. This is a very, very long time for a CPU. It's like
CP.
1 month has
Okay.
passed. Okay. So, uh, uh, so let's say, and for podcast as well, see, it is running at human speed, right? So, let's say for render 10 seconds of content,
Hmm.
CPU has to do some processing and it will probably be able to do it in 1 millisecond. So,
Okay.
in 1 millisecond, the CPU will do the processing and give the thing to the output buffer.
Hmm.
Okay. Now the operating system will slowly pick it out from the output buffer as needed by the video player.
Okay.
CPU is free.
Hmm.
So technically, what we are doing is we just the operating system will spin up two threads.
Then, 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 like if the CPU is really free,
Hmm.
then why, like it can only handle two programs at a time and not one time?
Yeah, it can do more
Because
than two. I'm just taking two example for the sake of simplicity.
you mean by the single core processing, right?
Yes. So you would have heard, right? Ki quad core and 4 cores and 16 threads. So 16 threads probably means it can run 16 different applications at the same time.
Mhm. Then why is it named single core processor if
Because
like
it
if
is not truly parallel. So if you let's say you are running, if you create a program which
Hmm.
runs a infinite loop. Okay, so technically we are not doing anything meaningful, but yeah, with this infinite loop we can occupy the CPU's core completely. So this whole core will be occupied. Okay, there can be a program. This is how malwares and viruses are built. One of the
Okay.
most simplest viruses are this. You just create an infinite loop, and the CPU's core will be blocked. And
So is it
if you
is
have
it
just
created automatically just because we are running too many programs at a time?
no,
So how is it a malware? Layer?
you write code for it. We will create this as well. You write code for it, and that code will be. And once you execute that code, one of your cores will be completely blocked.
Why?
Right? Because you are executing that program, right? So these
So
enterprise level programs,
the CPU is more than capable of running one program. So what if I execute one program? So what does it make any difference?
no, that is what I'm saying. The CPU is very fast,
Hmm.
but see, running paint and these things, these are not very CPU intensive tasks. Okay,
Okay.
so
So
like
running a program, like running a code, is also like a difficult math problem for CPU.
yeah,
It happens.
like if you
Okay.
have like 1 million lines of addition and subtraction, multiplication, division, this is a CPU intensive task. The operating
Hmm.
system cannot do anything here. It cannot optimize it in any way. The CPU will
Hmm.
have to do it on its own. So
Hmm.
to execute 1 million lines,
Hmm.
the CPU will have to allocate its entire code to this particular program. In this Microsoft Paint, Chrome, these are enterprise level programs. So they won't do anything stupid like this. Okay. This is what people like us do, right? Ki we have to make sure ki nothing like this happens. Otherwise, no one is going to use your program. Ki just
Hmm.
running one program and the whole core is occupied. Now you cannot do anything else.
Yes.
So no one will use your program. So this is just I'm giving you an example. It can happen like when you're running a game, when you're rendering 3D scenarios. Then in those scenarios, it is that is very much intensive.
Okay.
So in that case, your CPU will be blocked. So probably while running a game, if you try to run something else, your computer will hang most probably if you don't have very powerful computer.
Yeah. So that's why we have different gaming computers, right?
Yeah, or they have higher this configurations. Okay,
Okay.
so your single core CPU can have multiple threads. Multiple threads are nothing but a false sense of parallelism. They give you a false sense of parallelism, and they
So
are
what I understood is that
hmm,
suppose I am running a code and it's very difficult, so
hmm.
OS has nothing to do with the code, the execution of the code.
Yeah, OS can only
Easy.
execute the program,
Okay.
right? If it's a third party program, the third party program will do all the execution. That is why you get the warning
The main
also.
boss is CPU.
Yeah, CPU is the main boss. Everything else is just built on the OS is mainly built so that we can utilize this hardware, this piece of hardware in the most efficient way possible.
Hmm.
That is why we say, right, the heart is the CPU. And by CPU, not the, I mean, the memory and everything is also important because without that, CPU is nothing. But this is the most expensive and most important part. Okay. Like in a vehicle, engine is the most important part.
Mhm.
This is the engine. Okay. So, did you understand what is multi-threading? CPU core is a physical thing. It is a virtual thing.
Yes.
See, threads allow single core to handle multiple instruction streams concurrently.
So
Okay.
can we say that threads are the fire medium?
Threads are the
Like it's the medium,
medium of what?
medium of a code to handle multiple instructions.
Medium for the core to handle multiple instruction. Yeah, you can say that. Yeah, this is what is written, right?
So when you were learning this thing, so back in the school time, did you ever think that you will be asked questions like this when you will grow up?
Yeah, I actually did. That is the best way to study. You imagine what can people ask you.
Okay.
So
But has anybody else asked you this question?
no, no, no. So this reminds me of a very famous quote by Albert Einstein. See, if you can't explain it, you
You
don't
don't know it. Understand.
understand it well enough. Okay. So if you're not able to explain it, then the only reason is you don't understand it. If you understand it, you will be somehow able to explain it. Okay.
Maybe not like a pro, not like
Yeah.
our teacher does, but anyways.
So we have Intel hyper-threading, AMD simultaneous
So
multi-threading.
so here in my computer it's written AMD Ryzen, AMD Radeon.
AMD. So okay, we'll do one practical thing to make things interesting. Go to your this PC, go to your properties.
Wait, 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 wait,
Okay.
wait, wait. Getting excited. Practical thing is always fun.
Yeah.
I actually searched this PC and then it opened up. What do you mean by this PC? Yeah, I went to this PC and then
Okay.
so I can see Windows C and local disk D.
Yeah, so right click on this PC and
Go to
open
properties.
properties. Hmm. Okay, they keep changing the UI for some reason.
So it's so the processor name is written, that RAM is written, graphics card and storage.
How to find the codes and threads of your PC? Task manager. Okay, go to task manager.
Okay.
Okay, and once you are there, if you go to performance, yeah, see, very interesting thing. Are you able to see this?
Yes, yes, yes.
So I have 16 cores on my machine. So I can run 16 processes truly parallelly. Okay. And
Mhm.
look, there are these many threads, like around 12,000 threads, just running on the 16 cores. 12,000 threads. That means 12,000 processes.
So you have 16 ports.
Yeah. What about you?
I have only six.
Okay.
And 6,700 something
6,000 threads,
threads.
right? So you are running these many processes at the same time.
Hmm.
It's crazy, right? So
Hmm.
even a single core can probably run around 1,000 processes because
Yeah. So
each
the
process doesn't require CPU that much.
okay. And what does handles mean?
There is something else, even I don't know. We can
Then
see,
there
but
is L1
let's.
cache, L2 cache, L3
Yes,
cache.
this is the
What
cache.
is this?
This is near your CPU. Okay, hold on.
So, like when I want to buy a laptop, what should I look for?
Wait. 1 second. I'll be with you. Give me a moment, okay? All right. Hmm. So we saw, right? Ki... So did you
So,
understand what
when
is
we are
multi-threading?
saying that utilization 16%, 20%, 8%, so it means that CPU is utilizing this percent of it.
CPU, this much is, this is how much the CPU is utilized.
Okay. Okay. Okay.
Okay. So you can say you're not even utilizing the 100% of the CPU because the programs are made in such a way that you only use the CPU when it's absolutely necessary. You don't waste the resources. Okay. See, while threads improve efficiency, they do not double the performance. Only the cores can double the performance. Threads cannot because resources are shared between the threads. Right? I have only 16 threads, but I'm running 11,000 16 cores, but I'm running 11,000 threads on it. Right? So this means that a lot of threads are using the same core. It's just
Hmm.
that they're using one by one or in a particular, or they have synchronized the thing. Okay.
What is the use of thread?
What is the use of that? Use of what?
What is the use of thread if it cannot like improvise the performance?
No, it can. It gives you the sense of ki you are doing a lot of things. Like I'm running more than 16 processes. Had there been no threads, I will be only able to run 16. Okay, you have
Okay.
six cores, you will be only able to run exactly six processes, right?
Yeah. So thanks to thread.
Yes. Okay. I mean,
Hmm.
this is a little difficult to understand. Even I did not understand it the first time, so it's fine. But I'm sure you got some idea. What is it? So these things, we'll come back to this tomorrow. It's very interesting. Okay. Time sharing OS. Now we are back to the types of operating systems. It allows execution of more than one task processes concurrently. The processor time is divided among different tasks. The division of time is also called time sharing. So this is similar to this round robin we saw, right? Ki after 5 seconds, even though your process is hanged, the operating system will pick up the next process and not wait for that first process to complete. Okay.
So just like I'm printing some documents and along with I'm listening to podcast and like, typing something else.
No, no. Do you remember what is round robin?
Yeah, you told me right. Like um in round robin you gave the 10 kids example, right?
No, that was spooling.
Wait, just hold on.
Okay. So it's fine. See, I'll explain it again.
No, just hold on. Okay. So isn't it the simple way of giving everyone or everything an equal turn?
Equal what?
Turn. Like the
Turn.
CPU
Hmm.
gives each process a fixed amount of time.
Yes, yes, yes. So, what is the advantage of round robin scheduling?
Hold on.
Hmm.
So it's like a mother, like it gives fair chance to all her kids. It's fair to all processes, and
Hmm.
every process eventually gets CPU time, and none are ignored forever.
Are you Googling it and telling me the answer?
Fuck you. You can Google it. Will you get this answers from Google?
Okay. So, there are two algorithms, scheduling algorithm. One is uh, priority scheduling, and the other one is round robin scheduling. So, which one of these will give you better response time?
Better response time.
Hmm.
Priority one.
Priority one will give you better response time.
Yes.
Why is that?
Because it will give priority.
See, let's say Microsoft Teams had the highest priority. Okay, it had
Yes.
100.
Yeah.
And your Slack, it had priority of only 90. Okay.
Yeah.
So with the priority algorithm, Microsoft Teams will be given more priority and this will start executing.
Executing, yes.
Okay. But let's say because of bad weather, Microsoft Teams is not able to complete its execution and it's stuck in a deadlock.
Hmm.
Okay. So now the CPU is engaged. Or let's say it is infected and there is an infinite loop or something. The CPU is infected and the CPU is not able to complete the end the execution. So your Slack is also not getting opened. So you have opened the Slack, but it is you are not getting anything and you are just getting the loading on Microsoft Teams. So this is like very, very poor response time. You clicked it like 1 hour ago and
Okay.
still your Slack is not opening even after 1 hour.
Hmm. Okay, got it.
So
Now I
what
got it. Now I
so
finally got it.
so which
So the
algorithm will
round
give you
robin is
better
better,
response?
yes.
Round robin give okay. And why?
Because the CPU gives each process a fixed amount of time. Like process A, 2 seconds,
Hmm.
then the process B also the same time.
But let's say process A is not able to complete in that 2 second
Then
time
it will
period.
automatically like open process B, execute process B.
Okay.
Yeah. It will not wait for process A to get executed.
Hmm. Okay. So this is what a time sharing OS will do. It will use round robin scheduling algorithm and okay.
And it also prevents one process from locking others. So it is better.
Yes.
But
Okay. Good. Now that you are happy, then there is real time OS for robotics. Tasks have to be done within a fixed deadline. It's good if the task is finished within this deadline. If not, then situation is called deadline overrun. Alright. Distributed, like AWS has this distributed operating system.
what does it do? Is reliable share data on class system.
So its data is on multiple location.
Okay.
So it is used on networks to allow between all the machines on the network. Hmm. So the user you will feel as if like when you work from your laptop, you feel ki all the data is present on your computer, but all the videos or whatever you're seeing that is not on your PC. It's on some server in probably in another country, but you feel as if the data is on the workstation itself.
Exactly, yes.
Hmm. You probably don't use distributed OS, but I'm just giving you an example. Interactive this. So like the Windows 10 or Windows 11, whatever OS you are using, it is probably a combination of these operating system. It has real time, it has time sharing, it is a multi-processing, multi-user. Okay.
Okay. So it has okay. So what like Windows 11, look, one OS can have this kind of
Yes. Like your
features.
Windows has GUI, right? All this you are saying this is GUI. If you download the Linux server operating system, there is a
Hmm.
server operating system, there will be no GUI. You'll have to do everything from the command line. Okay.
What does that mean?
That means you'll only see a terminal like this. When you turn on the computer, you will see
Hmm.
this. Now you have to type and create file. Whatever you want to do, you have to do from here. There will be no UI. Okay.
Okay.
Yeah. Windows, Linux, boss.
So that will be very boring.
That will be very.
Boring.
No, actually it's not. It's very useful and it's easier to use.
So you like that?
Yes.
भारत ऑपरेटिंग सिस्टम सॉल्यूशन है.
Yeah, Indian distribution of GNU Linux. Because Linux is open source, you can copy it and make your own version of it. Okay.
भारतीय. Okay.
Linux operating office. This. It is a multitasking, multi-user operating system originally developed in 1969 at Bell Labs.
Hmm.
See, as I was telling you, OS can be multitasking, multi-user, time sharing, a lot of. Solaris, used by Oracle. Okay, mobile OS we have seen. You'd have heard about Symbian OS.
Yes.
Okay, see Android and Symbian. Android we have used. Symbian was used by Nokia.
We use Nokia mobiles.
What?
We used Nokia phones.
Correct.
It used to be great.
Hmm. See, no. The important part.
Okay.
See, we know the computer understands instructions in machine code. I told you this, right? That
Mm-hmm.
is in forms of zeros and ones.
Yes.
So it is difficult for us to write computer program directly in machine code.
Yes.
Make
Because we are
sense?
not that smart enough.
Hmm.
Okay.
So the programs are written mostly in high level languages like this
Hmm.
basic C++, Python. So a program written in any high level programming language is called the source program or source code.
Okay.
Okay. So now you know what is a source code.
Hmm.
See, now the source code cannot be directly executed by the computer.
Okay.
It must be converted into machine language to be
Yeah,
executed.
you told me that. Yeah.
Yes. The program translated into machine code is known as object program or object code.
Yes.
Okay. Now a
Yes.
special translator system software that is used to translate the program written in high level language into machine code is called language processor or translator.
Yes.
Okay, and these translators can be either assemblers, compilers, or interpreters. There are only three types of language converters which convert
Hmm.
high level to machine code.
Low level.
Assembler will convert into assembly language. I showed
Hmm.
you what is assembly language, right?
Yes.
Compiler is this,
Yeah.
uh, which converts this. C++ have compilers and Python has an interpreter.
Right.
So what is the difference between compiler and interpreter? Compiler will convert all the source code in one go, whereas interpreter does it one by one.
Okay.
This has its own advantages, we'll see, but just remember this much. Okay. Only
Okay.
after removal of error, the interpreter moves to the next line for execution. Can you stop with this?
Okay. Okay.
Yeah.
Isn't it cute?
Yeah, it is, but we're studying now.
Okay.
A software utility is one see utility we know this disk defragment, backup, compression, antivirus. All this is utility software, not
Okay.
important.
Like I bought this laptop
Hmm.
and I get this pop-up that please renew your antivirus, blah blah blah, whatever it is.
Not
So
it.
it isn't needed, right?
No, the Windows has sufficient security
So then why do I get the pop-up every day?
because you bought it once and they want you to buy it again.
Okay, okay. So is the Windows security system is as strong as the Mac OS, like the MacBook or something?
See, Mac is based on Unix,
Hmm.
and the main USP of Unix was security and privacy. So because of that,
Okay,
it's a little bit better. Windows has its focus on like penetrating the market. So it has loosened its security so that it's easier for people to use and
okay.
transfer files and interact. But while on Mac, it is because of security, it's sometimes difficult to transfer some files or do certain things. So it has this
But why is
trade-off.
that? Then what is the use of a laptop if you can't transfer files?
You can transfer files. You can
Okay,
like you won't be able to connect your HDMI. Like if you want to connect your Mac to a projector, you won't be do it.
okay,
You need a different converter. You need extra hardware to do that.
okay.
It's actually impossible to do it.
Hmm.
There are a lot more things.
Okay.
See, this is an interesting thing. There is a boot sector virus.
Hmm.
This displaces the boot record and copies itself into the boot sector.
What is boot record?
We studied right in booting. The very first program which is loaded by the BIOS
Okay, okay,
into the
yes, yes,
RAM.
yes, yes, yes.
Boot sector is where the program to boot the machine is stored. So
Okay.
first the virus will be loaded onto the main memory and then the operating system. It's a very smart virus. So whenever a new disk is
So,
inserted, the virus copies itself to the new disk.
so it's like a coronavirus.
You can say, okay.
So, what is the best way to prevent it?
So antiviruses can do it. I mean, it will not get on it unless without social engineering, it's almost impossible. Until
Okay,
unless you give someone your password or give someone something, it
okay,
won't. It will never happen. Or if you download something from the internet,
okay.
until then, it's not possible.
Mm.
Okay, so antivirus will override the correct boot record on the infected boot
Mm.
sector and cleans the bad sectors. Okay, file virus is using executable files. They will make you download these files from the internet, saying it's a game or it's a music or whatever, and they can attach to various locations of the original file. They'll replace the code and fill in open spaces in code. Okay,
Mm. Okay.
macro virus. This infects an important file, normal dot ms word. As soon as the application is opened, the virus gets activated. Damage the
Mm.
formatting of documents and even may not allow editing or saving of documents. Trojan horse, very famous thing.
Mm.
If a code, it is a code that is generally hidden in games or spreadsheets. Since they're
Mm.
hidden, the program seems to function as the user wants, but actually
Mm.
it's destroying the program. A Trojan horse does not require a host program to embed itself. It is a complete program. Its main objective is to cause harm to data. They can create bad sectors on disk, destroy files, allocation tables. That is the FAT file allocation table, and cause system to hang. Yeah, this is very dangerous. Worm is a program capable of replicating itself on a computer network. Worm does not
Mm.
require a host as it is a self-contained program. They generally
Mm.
travel from one computer to another across communication links on network. They generally disrupt routine services. Okay.
Okay.
I mean, these are
So
things
how will
you
I
remember.
understand that if I have one of this in my lab?
Antivirus use Windows Defender. Do the scan.
Okay.
It will find out.
Okay.
I mean, these are well-known viruses.
Hmm.
So people rarely use them nowadays.
Okay.
This is a utility software.
Uh, outside this
Okay,
box.
let's continue because there are more things to discuss.
Okay.
Let's continue tomorrow.
Okay.
Okay.
Okay. Okay.